Welcome to Unscripted with Jeff Pijanowski. I sit down with remarkable people from very different worlds, security and science, business and medicine, technology and the arts, for honest conversations about AI and where it's taking us. No scripts, no talking points, just what they actually think. I'm Jeff Pijanowski. Let's get into it.
We spend all our time talking about AI models. My guest today works on the thing that nobody sees, the staggering amount of data that these models have to eat. Keith Pijanowski spent over a decade at Microsoft and built data pipelines at BNY Mellon, and now he's a specialist in the storage and infrastructure that AI actually runs on. Every impressive AI demo that you've been seeing, it sits on top of an enormous, expensive, and very unglamorous foundation of data, and Keith is one of the people that built it. So I wanted to get a view from the basement of AI, what it really takes, what it really costs to feed these things. Keith, welcome to Unscripted. Let's get into it.
Yep, thanks for having me.
So a lot of different opportunities to get into tech. And what was your passion for starting with this? How did you get involved in the data world?
Well, to be honest with you, I feel like I didn't have any say in the matter. It selected me. I was.
You were volunteering.
Kind of a funny story. I was at BNY Mellon. I was a little bit bored. Sometimes big banks can be a little slow moving, and I had been dabbling in AI. I'd done a few side projects with it. And I looked at my LinkedIn profile and I was like, wow, my LinkedIn profile is really messed up. All I'm talking about is what I've done. I'm not talking about what I want to do. So I redid it. And literally like a week later, a headhunter called me up, said, hey, there's a startup. They do AI storage. They need a lot of help. They need help from someone who can code, who can author white papers, who can get up on a stage. Would you be interested? And the rest was history. That was like 3 years ago. I've been doing kind of AI infrastructure ever since then.
I mean, the public side of this, right? Everyone's like, oh God, the AI uses all this power. Why do they need these big data centers? And it is software at the end of the day. But I guess for someone that builds the infrastructure, what's involved? Why does it need so much to run?
Well, AI is a totally different workload than the software industry has really seen before, especially generative AI. And there's really two workloads to consider. When people say AI, there's two workloads. There's to train the model, and then to run it in production, have it actually produce useful results, which is often called inference. When you're training a model, don't think of a single model and a single GPU, and you got a single connection to your storage. To get it done in a reasonable amount of time, it's done in a cluster, sometimes hundreds of GPUs. And when you do something like that with high-speed GPUs, you got to have a fast network, and you really have to have really fast storage. Think of all those hundreds of GPUs requesting data from your storage over your network for days on end. Sometimes the larger frontier models take a couple of months to train. So that's training. Once you get to inference, you would think that you really wouldn't need fancy storage or a lot of infrastructure. It's just the model that's answering questions or giving you a prediction. But the truth is, some of these fancier models, their internal workings, and you have to keep me honest, I don't want to get too technical here, but they create something called a KV, key value pairs, as they're making predictions, especially the large language models. And you can get a whole lot of better performance if you can cache those calculated key value pairs in the correct place. So what you're seeing with inference these days, especially with agents and generative AI, is that cache can either take the form of GPU memory, system memory, local storage, or network storage, and you choose where it goes based on how long-lived you want it to be. So you put all these things together, and it's really you're really not just putting a simple microservice in production.
It's just for me, it just feels like a full circle, right? Because when computer systems were first built in the 40s and 50s, right, there was these huge machines with rooms with vacuum tubes and all that. And, there's more computing power now on our mobile phone than there was in the systems it took to send man to the moon, right? But now it's in a fraction of size. So is this more of an engineering issue? Like as AI scaled, we just haven't figured out how to design this in a way that's compact and efficient? Or is this truly something so different than what we've had to build before?
Well, I think it depends on what you want to do. So the question is, are we still? Is it still really efficient because it's brand new and we're just throwing resources at it just to get it to work? I don't think that's true. When you really look at, especially with generative AI and agents, when you really look at the computations they're doing, you really do need all those resources. Now that being said, there is a lot of work being done to make those models smaller. So again, I'll get a little techie geeky here, but you can take the data types that they use and smush it down to just maybe an integer that's four bits long. And sometimes those models can run on a desktop, or I think they're even trying to get them to run on a phone. So short answer is, to do the hardcore AI, you really do need all those resources, but there is efforts underway to.
From an infrastructure perspective, will quantum make the problem better or worse?
Oh, that's interesting. A lot of times when you have like a new capability like quantum, someone invents all new ways to use things, and then you're back to the starting point. But if you just look at face value, quantum computing could be the boost in performance that we need to just do some really, really efficient things with AI.
There's a lot of talk now in the news, like last week, China's coming out with much more cost-efficient models. And part of it is, I think, because they steal our shit. But is there, from a technology perspective, though, are there things that China's legitimately doing that we should learn from?
I mean, what they've done with being more efficient with training and developing models that are like 95% or around 95% as accurate as ChatGPT, but using way less resources. That's something we should definitely look into. But the interesting twist to that is that they used our frontier models to train their efficient models. So someone's got to build the frontier models. So I always counter, kind of that argument, like China's ahead of us or whatever. Someone's got to be pushing the boundaries with the frontier models, and you're not going to do that with distillation training and things like that.
All these things are trade-offs, right? We want our apps, we want our streaming, we want our content, we want everything. We don't often think about what it takes to power that. Is AI and all these data centers just capturing attention because it's easy for the news to talk about and galvanize it? Or, because we have huge Amazon warehouses, we have other big buildings for our infrastructure. What is it about AI that's capturing negative emotion?
You mean like with respect to conservation and environmentalism? Yeah. It is a power hungry technology. I mean, if you take a look at the super pods that NVIDIA is putting together, which have thousands of GPUs, and you look at the power requirements for those, it'll blow your mind. I mean, I was having a conversation with someone who's more in the putting together the data center, and he took a look at the power requirements for NVIDIA's latest superpod, and he was shocked. He was visibly shocked it was that much power. So, and it's kind of interesting, and I kind of do have like a little bit of a prediction. Everybody looks at the infrastructure needed, and it all revolves around the GPUs, and these GPUs are really rated based on their performance. But I think going forward, as AI gets more power hungry, you're going to see power ratings be just as important as performance. And I know NVIDIA especially is working really hard to make their newer GPUs much more efficient.
We're already, even without AI, there are parts of our country that are power starved, right? We're seeing the Colorado River, right, go down to record lows because that water is being stretched. We're seeing rolling outages in populous areas. Our grid, our power infrastructure wasn't designed not only for the population alone that we have now, let alone something like this. So what needs to happen from both a government and private enterprise, not just to build the data centers, but what do we need to do to upgrade our power infrastructure?
I mean, I think it has to be, shared responsibility. I think a lot of times, when cloud computing was first getting off the ground, even back then, power was a concern. You only built a data center where you could get cheap power, and it used a fair amount. So you had to check and see if it was okay to do that to that power grid. That has to become more and more prevalent, especially with these AI data centers. You can't just have like the hyperscalers or the neoclouds building data centers wherever they want, plugging in and expecting everything to work. It's got to all be planned out ahead of time. And if there's not enough power, I think it's got to come back to the whoever's building those data centers to help fund that and improve it so it doesn't hit the local community.
I mean, this is always a case of not in my backyard, right? We know we need prisons, we need airports, we need all these things. We just don't want it next door. We don't want airplanes, but they got to be somewhere.
Right.
How do we balance this out? I know there's been some talk lately about putting these things in space, perhaps putting them in the ocean. How real is that?
I think putting data centers in space is unrealistic. That just would be way too costly. Putting data centers in the ocean is interesting. I think that could be done pretty efficiently, and you get cooling. The benefit there is that you can get cooling just from the ocean around you. So that's something I would pursue before putting things in space. I think putting data centers in space is a little bit science fiction, in my opinion.
Probably easier to put it in the ocean before we put it in space, but we are. We're talking about going to Mars within the next 10 or 20 years, so you never know. That's a long way to get AI to come back. So over this time now that you've been working on infrastructure, is there a belief that you had for a while, but that you recently changed your mind about?
Well, it's interesting. I've been when I started my career, it was before the internet. So if you wanted to send a mail to somebody, you had to do physical mail. Then the internet came along, and then from there it went to kind of connected systems, mobility, cloud computing, and all these software innovations were pretty much, I'll say, unconditionally good. If you have kids, you could argue that mobility maybe is not a benefit because they play TikTok too much. But when generative AI came along, that kind of undermined my belief that all software innovations could be 100% good for mankind. And the reason is I've seen a lot of use of generative AI that takes away from our understanding of what we're really researching. So concrete examples, I've seen marketing personnel that put together, blogs or whatnot when they really don't and they use generative AI and they really don't understand what they're publishing. I've seen live programmers that, they generate code, but then when they run out of tokens, they're done for the month. And my big concern is at what point do we stop using generative AI and say, okay, I got to make sure I understand what this thing's generating so that I don't just become an operator.
What is it that people get wrong about the models, I guess, and not understanding what's happening from an infrastructure perspective?
Well, it's not so much the models that I'm concerned about, but it's more, human beings. You should really understand what you're doing. If you're in the business of communicating without a technology, you should really understand it yourself. You should always be the human in the middle between what a generative AI model develops and what gets published. And you should, like I said, it's all about understanding. You should understand it. So same thing with vibe programming. You shouldn't take code that's generated and put it into production unless you code reviewed it and made sure it passes all your unit tests. That's just, to me, that's just fundamentally wrong. You're just asking for a lot of problems if you do business that way.
I mean, vibe coding is cool in a lot of ways. It makes it easier for, let's say, a lay person or a business person to build something that previously they couldn't do. But you're arguing, of course, the flip side, because how many vibe coders actually understand from an enterprise perspective what's really needed to take it from just a little tool or a widget to an enterprise app?
Well, I'll give you a real world example about some of the things that could go wrong with vibe programming. So vibe programming is here to stay. Let's be clear about that. I've done it. You can ask it to build entire classes or functions, and it'll do it in a matter of seconds when it would have taken you maybe an hour to look up. So that's not going away. But when you code as a human being, when you're a programmer and you write code, it's really easy for you to fix your own bugs. So as you get closer and closer to production, you find more and more bugs. And if you wrote that code, you can fix it really easy and just keep things moving. The problem with vibe programming is that if, whether it's Claude code or whatnot, if it generated a bug, it may not know how to fix it. And now you're left with all this code that you have to go review yourself. And I've seen, engineering teams just come grinding to a halt because they vibe coded all this stuff in the beginning of their sprint, and then they get to where they have to put in production, and there's nobody available who actually understands the logic that can fix the code. So again, going back to my point, I really think with generative AI, whether it's generating documents or code, there should always be a human in the middle that has a full understanding of what's getting published or put into production.
Doesn't that, in some ways, fundamentally gets harder, right? Because a human in the middle has to know a lot more, because there will be less. If we need less coders, because even with forget vibe coding, just AI in general is starting to take on projects and sprints and streams and build the code. And then once it's up and running, whoever is there, right, has to know not only how the agents are working, but the various systems, the infrastructure. So it's a lot more knowledge.
Yeah. And again, vibe coding it's a productivity feature that engineers should absolutely know how to use. But again, like there's got to be a human being that knows more. That's somewhere on the team. For when
Keith, like guys like you, me, who've been coding and doing this stuff for a long time, we're already seeing them decline computer science degrees, because the jobs aren't available. How does someone get the experience now? Do they have to be a vibe coder themselves, and then figure that teach themselves before they can get hired by a company? Like, how do you get the 20 years of experience, 30 years of experience like you and I have? It's a really interesting phenomenon.
I think a lot about that. So let's focus on the vibe coding. I think what has to happen is some best practices have to evolve for using vibe coding. Right now, it's the wild west. People are generating code, throwing production, and let Claude do their pull requests and all this stuff, and bragging about how much code they wrote. But sooner or later, like I said, someone's got to develop some best practices. And what I find myself doing is when I asked, whether it's Copilot and VS Code or Claude Code to generate code, just give it a quick code review and make sure you understand all the idioms that are being used, all the resources that your code's using, and that you agree with it. And that doesn't take long. That's time well spent, and you're going to learn too. I've found that a lot of these LLMs that generate code, they know techniques that I didn't know about. So I've learned myself. So best practices like that, like putting yourself in a review process, could be a way to address what you're concerned about, how you get experience really fast and coding doesn't become a lost art.
Well, I definitely think there's broader implications, not just for coding, but on education in general.
Yeah.
How do we prepare today's young students for tomorrow's workforce? it's unquestionably changing. I think it's just a question of how much. And so as we think about our kids and potentially our grandkids, what world are they inheriting? I suppose that's every parent's job, right? We're worried.
Right.
What do you spend time worrying about with your family?
I think I wonder if AI is going to make the job market like super crazy competitive. I have two daughters in college, and I kind of wonder about what the job market will look like once they graduate. Will AI make obsolete maybe some of the careers that they're targeting, or just make it super hard to get a job? That's one thing I worry about. But again, I kind of coach my daughters into always trying to be better than AI, trying to understand and make sure you understand everything that comes out of AI. That's one way to stay ahead of the curve.
So all three of our children are in their 20s, and they give me so much shit about AI. Like, they're part of that generation. They're rejecting it. They don't want anything to do with it. And I had this conversation with so many of my tech peers, and they're saying the same thing with their kids. Like, it's really ironic. Like, we've spent all this time pioneering and innovating in tech, and then our kids are just almost revolting against it. How are your daughters?
They revolt against it too. Especially my youngest daughter, who just graduated high school. She's seen a lot of her classmates actually do homework, submit things that are purely generated, get good grades for it, and have like a zero understanding of what's going on. So basically in high school, you get these homework assignments, and then they go and they work in groups to do something a little bit harder. And my youngest daughter just cannot stand it when, I don't know if she has a term for them. Let's call them like vibe students or something like that. Can't contribute in a group environment when computers have to be turned off and you're sitting around a table with the teacher looking at you and you have to put together something. So yeah, it's kind of interesting.
Is this a modern version of Cliff Notes for them, or something more sinister?
It's a modern version, but it's way worse, I think, because you can literally, and I've seen it on just some of the marketing teams I've worked for. You could literally turn in something or publish something when you have no understanding of what it is.
Yeah, and I think that's the downside. I mean, for me, I encourage heavy use of AI with my employees, but I want them to produce a better output together by collaborating. Yeah. I mean, so if I was teaching, I'd want my students using it, but if all they did was take my prompt or my assignment and they turned it in and then whatever it spit out, they handed it in, I'd give them enough, because that's no different than, paying the smart kid to do your homework for you. It's the same thing, right? But I want ask questions, challenge it. What did you do with it? Tell me what you learned as you interacted with the large language model to produce something uniquely yours that combined together. And that's something worth grading, because now you're interacting. Because I do agree, like, if all you do is copy and paste, you're going to lose your critical thinking skills really quickly.
Mm-hmm. And, I try to be careful about when I advise against using AI, because I don't want to be that farmer that's behind a ox looking at a tractor saying, "Oh, that's crap. No one should ever do that." I don't want to be that guy when with respect to AI. So I always think, like I said, I always think it revolves around best practices and making sure that you use AI as a productivity tool. I mean, there's no way. I do it all the time, for the record. I know we're kind of bashing AI a little bit here, but I use AI on a daily basis for research. You can just ask it a question and you get really good results. So again, it's a productivity tool, but you got to make sure it doesn't turn you into an operator.
And then even with that research, right? I mean, you got to read it, you got to interpret it, analyze it, think about what you want to do with the research. So yeah, I'm the same thing. I mean, I have all of them open, and I'm using them all day long. Like I'm interacting with it. At least I have somebody to talk to. Someone that talks back. But yeah, I think it's really an interesting conundrum.
Yeah.
And I don't know, like the train has clearly left the station, and I suppose every generation rejects some degree of what happened before. But it is concerning to me because how are they going to be functional if they're outright rejecting it when we know employers are hiring people now that need to be AI savvy and AI aware? So if this generation already is going to be facing a job shortage, and then on top of that, they're going to be poo-pooing like, no, I won't do anything if it involves AI. They're going to be working at McDonald's, I guess. I mean, I don't know.
Well, there's robotics. Robotics could take away a lot of those jobs, So
it could. Although I spoke with Klaus Nielsen yesterday on the show, and not so fast. Like it's very fascinating talking to someone that's an expert that designs these. Like, robotics are cool, but there's still a long way to go. Yeah.
And it's kind of a funny story. I'm not an expert in robotics, but I was at one of the NVIDIA GTCs, not this past one, but one before. And they did have robots walking around the trade floor show. But they're so expensive that there was someone right behind it ready to catch it in case it falls. So there's still, again, you're right. It's still a ways to go.
There's a job, right? Okay. So what are you going to be doing? Okay. So what you do is you follow behind this robot all day long. It's but we're going to pay you to be a trust faller.
Yeah.
But look, I mean, I think technology advances all the time, and clearly, I mean, I graduated too before the internet was here.
Yep.
And my first job was doing catalog marketing at a bank. And we literally sent everything out by direct mail. There's no email, no mobile phones, no social media, no influencing, none of that. And so you think about all the jobs and the careers that have emerged now in the 30 years since. It's well, damn, it's coming up on 40 now. I don't know, Keith, getting up there.
I know. No, like I said, I started my career before the internet. You could send an email to someone that worked at your same company, but if you wanted to communicate with someone in another company, you typed up a letter and you stuck it in that physical, and you were assigned a physical mailbox.
Oh, you were fortunate. We just sent smoke signals at my company. Do you have, with all these years of perspective now, well, if you had to go back and visit with your younger self, what would you tell them?
I would say, that's a tough one. I would say, first of all, I might give myself a compliment. I'd say because I always thought that once you graduated college, basically the rest of your life you should pretend like you're still in college. Make sure you always continue to learn. And I think I did well. I did well at that. But what I would tell them not to do is, and this is unrelated to technology, but I would say that every single mistake I made in my career was when I was angry. So I would say, if you ever get angry on the job, just don't say anything. Wait till you're not angry anymore to act.
Okay, I like that. So I know, growing up though, when you were a kid, did you dream of being a programmer, or did you have other designs?
I got through. It's kind of funny. I really did not know what I wanted to do when I was before I got to high school. I had no clue what I wanted to do. And when I got to high school, I knew that I was a little bit better in math and science than everybody else, but that still didn't narrow it down too much. And then I had this one teacher. She was our math teacher, but she took the time to put together a programming extra credit project, and I did it because I thought it was interesting. And one day she was looking at me work on the computer, and she just goes, "Keith, I think I could see you making a living doing what you're doing right now. You're like just in the zone, and you're figuring things out on your own and you're very happy with what you're doing, you should consider that. And the rest is history.
Was that one of the teachers that you remember if you look back?
Yeah, absolutely. That was probably one of the top 2 influential teachers in my life. Yeah, to say something like that.
Who was the other?
It was this ironic that had to do with sciences. It was just I went to a Polish high school where they taught us 4 years of Polish. So it was my Polish teacher, and he was just, I think he was born in a pickup truck during World War II, but he was just so worldly. He read a ton of books. You could talk to him about anything. He wasn't very narrow, and just going to his classes and listening to him talk, I knew that if you're really going to navigate the world and understand people, you have to be more than just a technologist. And I think that particular teacher kind of gave me a love of just reading books. You can see the bookcase behind me. Those are all books that I've read that my daughters haven't swiped from me.
That's awesome. So what are you reading now?
Actually, I am reading Daniel Kahneman's book called Thinking Fast and Thinking Slow. And it is kind of interesting. The reason I'm reading it is because I think the next great advance in AI is going to be someone who finds another way to emulate some other part of how our brains work. So he's done all this research on how our brains are composed of 2 systems. One that just makes quick, intuitive judgments because you have to protect yourself as you're walking through the world. And the other one that can think slow and really figure things out. And he really goes into how, bias is embedded into, the fast thinking. And it's very interesting to me. I can see a lot of things that someone who actually wants to invent the next AI, something that's just as impactful as the attention mechanism was for LLMs, would read this book and say, okay, I think we should try to architect our models in this fashion.
How do you decide what you want to read each week? Do you get recommendations or do you...
A lot of times authors, I'm a big fan of Steven Pinker. He's a professor at Harvard University. So I read a lot of his books, and a lot of times authors will mention another author that they respect. So if I'm reading an author that I really like, and they mention somebody else, I'll put that on my reading list. And I pretty much do that. And I've got a reading list that'll take me probably to the rest of my life.
So you did some editing for our anthology book at American Society for AI. Had you done editing before? How'd you pick up that skill?
I was, I worked 3 years at an AI storage startup, and I was on their marketing team. They wanted an engineer on the marketing team. And every time somebody wrote a blog post or a white paper, someone else had to review it. So it is a skill. How do you review somebody and not just totally trash it? How do you give them just the right amount of advice to take it to the next level and not rewrite their article for them? So that's where I kind of got my experience from.
Nice. You're a man of many talents. Whoa.
Try to be.
So reading, coding, being a dad. What other hobbies do you have?
I try to stay in shape the best I can. I'm a retired marathon runner. I used to run a lot of marathons when I was younger, and as I got older, that kind of transitioned into just trying to be as healthy as I can, just so I can live as long as I can. So I can't run anymore. I trash my knees, but I do everything else. I cycle, go to the gym, I do cardio, and also try to eat as healthy as I can too.
That's awesome. For me, like running to the mailbox, that's an accomplishment. Very cool. So getting back to storage, when does it make sense for companies to invest in their own storage versus just renting from a cloud provider?
Well, the first thing you got to realize is that if you're going to do AI and you're going to have dedicated storage for the data sets that you curate, you want that storage right next to your GPUs. Okay, you have to make the storage decision along with the compute decision. Okay, and then that turns into your full infrastructure decision. So what I always recommend is that you always start small. So and today that's really easy to do. There's the cloud providers, the neo cloud providers. You can rent just what you need and kind of get your pipeline going. But the short answer to your question is, with respect to storage, first figure out where you're going to do your training and inference, and then get storage from that provider.
We talked earlier in our conversation just about why they need all this power and the infrastructure that's required. Frontier Labs, hyperscalers, I mean, they're putting tens of billions of dollars into this. So, but I guess at what point is it stop being rational? And it gets to a point where we're creating like an artificial bubble.
I was thinking about that the other day, and I don't know. I think if I just think about my own usage of AI, I'm always I'm in a chatbot all the time. I am a little bit of a vibe programmer. I'm sending a lot of requests myself, and I'm just one person. And when I look around at how enterprises are really pushing their employees to use AI more to be productive, I just think I think the data center build out is kind of rational. It is real. And I can also tell you that, companies like I spent many years at Microsoft, and I was on the team that first was evangelizing Azure before it was even publicly released. I can tell you that the people that build those data centers, they don't do it just on a whim. Everything, that kind of money is researched. There's got to be legitimate demand. They got to know, companies like that have to know that they're going to make money on it from usage. So you put all that together, what I'm seeing enterprises use it for, consumers use it for, the research that hyperscalers put into it with the data they're seeing from usage, I personally think it's rational. It's going to be used.
But the models, I mean, they, in also other ways, they get more efficient, right? Mm-hmm. And that should be the goal. So if they continue to drive efficiency, though, do we get to a point where AI needs more infrastructure versus we've got so efficient we can just leverage the infrastructure we built? Like when does that story change?
I mean, the thing is that if models get more efficient, both the models themselves as well as the GPUs they run on, if we get more and more efficiencies, are we going to get to a point where we have more data centers than we need? And I don't think history has ever seen that happen. And it's a phenomenon called the Jevons paradox. And it was first observed by an economist in the coal burning days. And what happens is that when a resource is used more efficiently, companies that are already using that resource use more of it because they have things in their pipeline they want to do. Other parties that were locked out because of the expense can now afford to do it. And then when you have all this extra usage, someone invents yet a new use of it. So those are basically the three forces acting in the Jevons paradox. I think that's what's going to happen with AI infrastructure. So if the models get more efficient, GPUs get more efficient, more people are going to be able to do AI. People already doing AI are going to do more of it. And it's just we're going to need more and more resources in the end. I mean, fuel efficient cars are the perfect non-AI example.
So wait, you said we're going to need more resources at the end or less resources at the end?
More.
Okay.
Like fuel efficient cars are a good example. I mean, when cars became more fuel efficient, gas utilization went up because people drove more, and people who couldn't afford cars bought cars because of the fuel efficiency.
It's an interesting paradigm shift, right? I guess I suppose the same thing with our mobile phones, right? Is more apps become available, more things, you spend more time on it. So then you're using more resources to run those apps, right? So it becomes like a self-fulfilling prophecy as we do that. We get hooked to the machine.
Yeah. Yep.
Right. It really is. But are you concerned about that becoming like an addictive drug where we become too dependent on using AI that we lose our humanity in the process?
Yeah, I worry about that. And I think at the core, that's what I was trying to convey when I talked about, using AI when you don't even understanding what it does. I mean, if you think about the history of humans, I think one of the things that makes us incredible is we're always figuring out the universe around us, always making breakthroughs. Whether it's the theory of relativity or figuring out dark matter and dark energy, we're always figuring out how the universe works. And how do you keep that going when people forget how to understand things and figure out things for themselves because they're using too much AI? So yeah, I worry about that all the time.
So 10 years out, is AI infrastructure something that every company has to wrestle with, or does it just become a utility that we don't worry about anymore?
I think I don't know that it'll ever become a utility, but it'll get a whole lot easier to use. And I think it'll follow the same pattern as Kubernetes. So if you remember, Google open source Kubernetes, which is a way to do, distributed computing and manage massive amounts of microservices. But before Kubernetes, that was really hard to do. And then even after Kubernetes came along, Kubernetes itself was kind of a pain in the butt. And all kinds of other innovations came on top of that to just make it really easy. I think you'll see AI infrastructure kind of follow the same pattern. So right now, if you beam into any of the things that NVIDIA is doing, Jensen Huang's keynote addresses, you just see these super pods that are put together, and there are wires everywhere and different components. And it's pretty complex, but I think over time that's going to get encapsulated by easier to use technologies, and it'll just become much easier to use. But don't ever think it'll become like the highway system or the electric grid. I just think it's an area where there's just too many innovations, and those innovations will always kind of pull us back to a little bit of complexity.
I mean, I think it's interesting you mentioned the highway, because here in Atlanta, we're constantly expanding the major arteries, and then of course more people move in, and they have to expand again. Just because it's never in a perfect state, right? You're just going to be dealing with traffic forever. It's just, are you on a 2-lane road or a 6-lane road? Doesn't matter. So is there something that you're paying attention to right now that most people aren't?
So getting back to maybe just the infrastructure, what really interests me is let's just beam in. Let's make a really simple visual of what goes on with training or inference. You basically you have a GPU that's running a model. You have a network, and you got storage. The GPUs, they have gotten so much faster over the years. And I actually pulled up some stats. I want to make sure I'm going to turn on my iPad because I want to make sure I get these stats correct. All right, so if you were to compare the A100 to the Vera Rubin, which just got released, it is 13 to 25 times faster. And this is just in a span of about 5 years. And the memory bandwidth is 11 times faster. Okay, so that's what, so again, remember our super simple visual. You got GPU, network, and storage. If this GPU is getting that much faster in that short a time, is networking and storage keeping up? And what I'm looking for is the breaking point. when does the GPU become so powerful that our neglect of network and storage makes progress in the GPUs irrelevant? So if you have this super powerful GPU and it's just impossible to keep it 100% utilized, it can only be 60% utilized, then it's really useless. You're wasting your money. You may as well just have bought a previous generation and saved tens of thousands of dollars.
It's an ever-changing ball game, isn't it?
Yep.
All right, Keith, thanks so much for being on Unscripted.
Yep. Thank you. Thanks for having me.
You got it. We'll talk again soon.
Yeah. Bye.